Okay, hello again. So we are going to look at one of the classic types of series. Now that we have the integral test, we can talk about the convergence of a series we call p-series. Um, so so far we know about geometric series, and we can tell very quickly if a geometric series converges or not. And if it converges, we know it converges to, right? We know about the harmonic series, which diverges. We know about that sometimes series can be collapsing series. You can expand them using partial fractions, and you can figure out what they diverge to. And now we have the integral test that gives us a way to determine if a series diverges or not, or converges, and gives you sort of a way to estimate what it converges to. We're going to do more detail on figuring out the error in the integral test later on. But let's introduce this new type of series, p-series. What I've drawn up here, this thing, the sum I equal 1 to infinity of 1 over I to the p, is called a p-series. So we got a few examples here. The first one, I equals 1 to infinity of 1 over the square root of I. And in that one, p is equal to 1/2, right? The p-series is the power of the I. This other one over here is the sum I equal 1 to infinity of I squared, 1 over I squared, and that one p is equal to 2, right? Of course, be a little bit worried, careful, this could have been written like this, I to the negative 2, and realize that still is p equals 2. P is the power of the I in the denominator. So if I did the sum I equal 1 to infinity of I, that would be p equals negative 1, right? Because that would be 1 over I to the negative 1. 1 over I to the negative 1. Okay, so it's the power in the denominator. And then you should recognize this one here, the sum I equals 1 to infinity of 1 over I. What is that? Right, that's the harmonic series. The harmonic series is an example of a p-series. We already know if that one converges or not, right? That one actually diverges. Well, we're gonna see if we can come up with a general idea of when these things converge or not. Now that we have the integral test, it's a perfect test to work with on this thing. So I'm going to take the integral from 1 to infinity of dx over x to the p, of course, improper integral, that is the limit as t goes to infinity of the integral from 1 to t of x to the minus p dx, right? I'm going to rewrite that. And assuming p is not equal to minus 1, we'll talk about that in a minute. Assuming p is not equal to 1, this is going to be the limit t goes to infinity of x to the minus p plus 1 over minus p plus 1, right? And that's if p is not equal to 1. In other words, if my series is not the harmonic series, right? And so let's rewrite that. That's going to be limit t goes to infinity of, we can pull out that constant, 1 over 1 minus p times, and let's bring that p to the denominator, p minus 1. So I'm going to get 1 over, let me erase that. 1 over t to the p minus 1. You negate the exponent when you put it in the denominator, minus 1. Right? So what's happening to here? Well, what is happening to t to the p minus 1? The thing is if p minus 1 is positive, then this is something in the denominator going to infinity, right? If p minus 1 is bigger than 0, then this is actually going to, well, the denominator is going to infinity, so the whole thing's going to 0. If p minus 1 is less than 0, well, then when we rewrite it as t to the 1 minus p, this is bigger than 0, right? And that's going to infinity. So looks to me like if P, this converges, if P is bigger than 1 and it diverges if P is less than 1, right? And in which case, well, what happens at P equals 1? At P equals 1, we have the harmonic series, which diverges. So, in other words, we know exactly when these things converge and diverge. So, converges when P is bigger than 1 and diverges. Diverges. Diverges when P is less than or equal to 1. And that is the p-series theorem. So let's just point out this is going to diverge, right, because p is equal to 1/2. This one diverges. We know that already. This one converges because p is equal to 2. Even if you write it in this way, it converges. And this one, obviously, what's p here? P is -1. This diverges, and you can tell right off the bat diverges. Okay, that's p-series. Bye.